In this video, we're going to talk about different ways of collecting data. First of all, let's talk about types of studies. The first major type of study is an observational study. In this type of study, researchers only observe the behavior of individuals in the study. There's no attempt to influence the outcome, and some examples are things like surveys and follow-up studies. Another type of study is an experiment, or sometimes we call this a designed experiment. This type of study is much more controlled than an observational study. In an experiment, there are one or more factors that are intentionally varied. Each factor or combination of factors is called a treatment. The researchers assign individuals to different groups, and each group gets a different treatment. And then the effect of the different treatments is observed. When we talk about studies, we also need to talk about explanatory and response variables. An explanatory variable is one that's used to explain or predict changes in the values of another variable. This one's called the response variable. An explanatory variable is often also called an independent variable or a predictor variable. And in a study, the explanatory variable corresponds to the treatment or factor being studied. In an experiment, this would be the treatment that is being changed for the different groups. Then we have a response variable. For the response variable, the values change in response to changes in the explanatory variable. This is often also called a dependent variable. In a study, this corresponds to the effect being studied. Here's an example. Some researchers wanted to investigate cancer risk among Danish cellular phone users who were followed for up to 21 years. To do so, they kept track of 420,095 people whose first cellular telephone subscription was between 1982 and 1995. In 2002, they recorded the number of people out of those they were following who had a brain tumor and compared the rate of brain tumors in this group to the rate of brain tumors in the general population. One question we can ask about this is, was this an observational study or an experiment? Because the researchers were simply observing these phone users and weren't attempting to make any change, that makes this an observational study. In other words, all they were doing was observing the phone users. They weren't actually giving them any type of treatment. The next question is, what's the explanatory variable? In this case, the difference between the phone users that were followed and observed and the general population is that the ones being observed had their first cell phone subscription between 1982 and 1995. The difference between these people and the general population is the amount of their cell phone use. So we could say that the explanatory variable is the level of cell phone usage. The users who were being followed had had a cell phone for a long time, so they would have had a higher level of cell phone usage than the general population. The response variable is what was being recorded for these people, and that is how many of them had a brain tumor. They were comparing that to the rate of brain tumors in the general population. So this is the effect that was being observed. The response variable is whether or not a brain tumor developed. Now let's look at another example. In this one, the researchers were examining whether chronic exposure to radio frequency radiation caused brain tumors in rats. The rats in group 1 were exposed to analog cell phone frequency. The rats in group 2 were exposed to the digital frequency. The digital frequency is higher than the analog frequency. The rats in group 3 served as controls and received no radiation at all. The rats in all three groups were treated the same except for the RF exposure. The first question is, was this an observational study or an experiment? In this study, the rats were intentionally exposed to 3 different frequency levels, and then the effect was observed. That would correspond to 3 different treatments being applied, and that makes this an experiment. The explanatory variable would be the treatment that was applied, which would be the level of radio frequency exposure. The response variable is, again, whether or not a brain tumor developed. Another type of variable that we need to talk about is a lurking variable. This would be an explanatory variable that wasn't considered in a study, but something that might affect the value of the response variable in the study. In other words, it might be something that's lurking in the background and affecting the results. In the study in example 1, which was an observational study, there could have been many other factors that contributed to the likelihood of cell phone users to develop brain tumors. One would be family history. Another would be exposure to other known cancer-causing agents. In that study, because the cell phone users were only observed, there was no control for other types of variables. In the study in example 2, the rats in all 3 groups were treated the same except for the RF exposure. This was done to eliminate lurking variables. There are a few more terms that we need to define when we talk about experiments. First of all, a subject, or you'll sometimes see this called an experimental unit, is a person, an object, or some other well-defined item upon which a treatment is applied. In other words, it's an individual in the study that is receiving a treatment. A control group is a group that's given a baseline treatment or no treatment at all so that the effect of other treatments can be compared. This would be like the rats in the second example that didn't receive any radio frequency exposure. A placebo is an innocuous medication or a fake treatment, like a sugar tablet, for example, that looks, tastes, and smells like the experimental medication or treatment. Blinding is non-disclosure of the treatment a subject is receiving. If there is more than one level of treatment, or if there's a placebo involved, this is saying that it's not disclosed which level of treatment or whether the placebo is actually being given. In a single-blind experiment, the subject doesn't know which treatment he or she is receiving. In a double-blind experiment, the subject doesn't know which treatment they are receiving, and neither does the researcher who's applying the treatment. Here's another example. Let's say that the math department is considering using a new blended learning course format for intermediate algebra. To compare the new course format to the traditional lecture format, 3 different instructors will teach 2 sections of the course each, one in each format, this semester. At the end of the semester, all students will take the same final exam, and the scores for each instructor and each format will be compared. First of all, who are the subjects? This would be the students in the classes. What is the population for which this study applies? This would be all students who enroll in intermediate algebra, not just the students who are in the sections being studied this semester, but all students who enroll in intermediate algebra. What are the treatments? The treatments would be the course formats, which are blended learning and traditional lecture format. You could also consider the different instructors as being a different treatment. So really we could talk about the combination of instructor and format. What is the control group? This would be the students in the traditional lecture format sections. That's the baseline. What's happening is that the effect of the blended learning format is going to be compared to this one. What is the response variable? The effect that's being studied is the scores on the final exam. The last question is, why can't this experiment be conducted with blinding? That's because both the students and the instructors are going to know which treatment they are receiving. They will know whether they're in a traditional lecture format course or a blended learning course, and they'll know which instructor they have.